Okay, a couple concepts we want to work on today, solving logarithmic and exponential functions, and applying the change of base formula. Change of base formula looks something like this. We have log base b of m is equal to log base c of m over log base c of b. C just stands for a common log between the two. We think of common log as base 10, and we certainly can use base 10. In fact, it's the only thing I use. Okay? But log, a change of base, we want to change it to a log that we can apply on a calculator, and so common log is the easiest. We have log base 3 of 8. We want to know what that is, and our calculator doesn't allow us to change our base. Then we're going to say log base 10 of 8 over log base 10 of 3. If you keep in mind that the base belongs in the basement, okay, if you think about it that way, the base belongs in the basement, then the log base, or the log 3 goes in the bottom. And then log whatever this number here is will go on top. And so now we can use our calculator and just go ahead and type that in. Log 8 divided log 3, what do we get? And your parentheses. If your calculator does this, when you hit log, it does this, puts a parenthesis there, and you put 8, you have to end that parenthesis before you divide.
1.89.
You did it again?
No, I already did it.
I got 1.89.
Yep. Yeah, 1.89.
And what is it?
1.89.
Okay, if you don't end the parenthesis right here, then it's going to throw the log, divide by log of 3 inside this other log. And it won't be doing what you're thinking it's doing. It'll definitely give you a different answer. Okay? So make sure you end the parenthesis before you hit divide. All right, now those who have a change of base calculator, go ahead and do log base 3 of 8 and confirm we get the same thing. While you're doing that, I'm going to get this loading up.
Yep.
We're going to need this calculator later. I meant to get it going earlier. Okay? So we confirmed we got 1.89 both ways, didn't we? Okay. Remember, your calculator may need an upgrade to have that change of base feature on it. Okay? Hook it up to your computer and go to TI and do an upgrade. All right? Any questions on this? Okay, the next type of problem we have is, let's go 3 to the 4x equals 30. 32.7. We want to calculate what x is. It is very random. Okay? We want to calculate what x is. Well, this is an exponential equation, isn't it? And we can't raise both sides to the 4x root and know what we get because it's unknown. So I'm going to do this. I just want you to watch. Don't copy. I'm going to do this two ways. I'm going to do it the way the book is showing you, and I'm going to do it the way I'm showing you. And then you choose which method works best for you. The book is going to say, let's make this log base 3 of 3 to the 4x equals log base 3 of 32.7. So what they're doing is, because this is a 3, they're going to use base 3 and take the log of both sides. Okay? Now, I understand why they want to do that here, because remember that rule I showed you that says log b of b to the n is equal to n? Remember I gave you that rule when I gave you the other rules? Well, that means all of this on this side is simply equal to 4x. Okay? And then I can divide both sides by 4. Goodness. Won't let me write very well with the recorder going. Alright? Now, if your calculator doesn't do change of base, this gets kind of messy. Okay? You have to turn around then and say this is log 32.7 divide 4 log of 3. Okay? And if we plug this into our calculator and put parentheses around that, louder please. 3.17.
I got 0.7.
Oh yeah, I got 0.79.
Think you may have a parenthesis problem. Did you end your parenthesis before you?
Oh, I just did it with the already one on my calculator because I already have it. It's already got the change based on the calculator.
And then you have to run the phone.
Oh, I know.
Okay. Tell me what we get.
79.
Point what?
79.
Thought I heard a 4. 0.79. Okay. So we get something like that. Now, so change of base. I'm sorry, we went base 3 because this number was a 3. And then we had to change base in order to solve. Alright? If we took this same problem, 3 to the 4x equal to 32.7, and we just took the common log of both sides, we're going to apply the rule about the exponent, writing it out front. And so we get 4x log 3 equals log 32.7. And if I divide both sides by 4 log 3, okay, on this side, this all cancels. I'm left with an x equals, actually approximately equal to. And then again, make sure when you're dividing, you put that in parentheses, because we want to divide by the 4 and the log 3, not divide by 4, get an answer, and times the answer by log 3. Okay? And that's what will happen if you're careful with your dividing here. I believe we're going to get 0.79 again. All right? So there's 2 methods to do the same problem. If your calculator does not have the ability to write it as a change of base, like the simple TI that you're using, Mackenzie, you're going to want to do it this way. You really don't have an option. You kind of have to do it this way. Or you have to do this and then use the change of base formula on this part of the problem here and to get this last statement here. Okay? Others, if you have a change of base type calculator, you can do that in your calculator fairly easily. And so I'm not going to argue one way or another which is easiest for you. You just take it whichever one you want. The book does it this way. And I usually do it this way because I've never had a calculator that allowed me to change the base. And so this is just always the method that was easiest for me. Okay. base 10. If you use base 10, you don't have to change the base later. Okay? Any questions on that? All right? A problem similar to that, let's say we have 5 to the 3x equals 103.6. And I want to solve by graphing. Solve by graphing. And I have a little picture of your calculator here. Okay? That's your calculator. Looks a lot like it, doesn't it?
Yeah.
Okay? Good. So, what we're going to do is we're going to say y equals 5 to the 3x and y equals 103.6. Nice 6, wasn't it? And so actually we're going to say y1 equals 5 to the 3x and y2 equals 103.6. And we're going to plug these into our calculator and graph. And so um, 5 to the 3x and what they say 103.6. Okay. All right. So you can't really see my blue graph anymore because it's blended into the x and y axis that were so close. But we're going to go to menu, go to analyze, and find the intersection. This would be easier if I use my mouse. Left side, right side. Oh, that's not quite right.
You're at 0.96.
Oh, that's 103.6. Okay, it just changed it to 104. I guess it felt that was so close, we'll just call it 104. I thought maybe I accidentally moved my line, but anyway, I did. So the answer is 0.96 is my x value. Okay? So by graphing, I'm just going to type y1 is equal to this side of the equation and y2 is equal to this side and find the intersection. Okay? That's going to be the easiest way. So we got 0.96, is that right?
Yeah.
Let's test it just for kicks. What is 5 to the 0.96 times 3? Sorry, I said 96 and wrote 95. Is that really close to 103.6?
I don't know.
Okay, well, remember it was 0.961 something?
I got 103.04.
Okay.
Yeah, that's,
Yeah.
yeah, that's what I got.
Yeah, and so, if we went back to our graph, see it was really 0.961, and that's just rounded to the third decimal place, so, oh, that's why it rounded this off to 104. I'll have to go find the settings that allows me to carry more decimal places, that's why I did that. Okay? All right. So we get close, okay? 103.047. Okay. All right. Last concept. I don't want to make this one up.
was that?
Since we're recording, let's get back on task here. Okay, what's the base in this log? Okay, and so if I rewrite this, hey guys, if I rewrite this in exponential form, it's going to be 10 to the, no, 4 equals 2x minus 2. Remember the 10 came from here, so this is the base to this power equals this number. That's how we rewrite it in exponential form. And so this is 10,000 equals 2x minus 2. So if I add 2 to both sides, 10,002 equals 2x divided by 2, we get x is equal to 5,001. So if the problem is in logarithmic form, we're going to write it in exponential form to solve. Okay? If it's an exponent we're solving for, so it's an exponential form, we're going to take the log of both sides to solve. Okay? 3 log x minus log 2 equals 5. 3 log x minus log 2 equals 5. Now how would I solve that?
Find your log.
What's that?
Wait, we find your log.
Find our logs?
Is that log with a base of 2?
No. No, it didn't look like that, didn't it? Maybe I wrote it that way, I didn't mean to. Log 2. Thanks for catching that. I don't know if I did that or if the recording did that. Probably I did.
Log 2x to the power of 2.
Say that again?
Log 2x to the power of 2.
So you,
Log x divided by 2 to the power.
okay, so she's saying I want to combine my logs since they're the same base 10. I want to combine my logs. I agree with that, but I'm going to slow it down. This is log x the third minus log 2, right? There's not a 3 in front of that second log. So then when I combine them, I get log of x cubed over 2. Now you might have been saying that, but it sounded like you were raising the x divided by 2 to the third power. The whole thing, not just the x, okay? So this is the right way of writing it anyway. Now what's the base? 10. So 10 to the 5 power equals x cubed over 2, right?
So 100,000 times 2.
10.
No, it's 100. 5 zeros. And so 200,000 equals x cubed. And so if I cube root both sides, I'd have to look at the question on whether they want this rounded or if they want it simplified. In this case, they rounded.
It's 447.21.
Cubed root. I didn't put that in yet. I got distracted thinking about what my answer is going to be. And taking cube root of both sides.
58.48.
Yeah.
58.48.
58.5.
Yeah.
Okay? Any questions on that?
Well, people blame me, I'm not contagious.
Okay. Remember our assignment, lesson 5. kind of an odd assignment. It's 3, 13, 23, 33, 76 through 96 evens, and then the checkpoint quiz.
Can you say that again?
Yep, it's 3, 13, 23, 33, 76 to 96 evens, and then the checkpoint quiz.